Welcome to Chapter 8. Well, the rest of Chapter 8, I should say. It's hard to believe that the semester is almost over. Hope you're all hanging in there. And in this video, we're going to be continuing our discussion on chemical equations. And before, I was giving you chemical equations to balance, and we didn't really know what type of equations they were and what type of reactions they represented. So we're going to begin to understand that in the remaining sections for this chapter. So we want to be able to identify the chemical reaction that's going on and then be able to balance it. And we'll see some examples of that as we go through and write these chemical equations. So the first chemical equation we're going to talk about is a combination reaction. And the name kind of gives it away. If we had a definition for a combination or a synthesis reaction, which is another name for it, it's when you have two or more substances combining to form a single product. So that's the key here. As shown here, you have two distinct things coming together to form one new thing. Right? So that would be the definition of a combination or a synthesis reaction. Two distinct things coming together to form one new thing, a single product. Okay, so what type of problems are we going to be doing given this knowledge? Well, let's do a few. So here's some typical problems you'll find in the homework, in a lab that you have to do, in quizzes and tests. You're going to get a lot of practice doing these types of problems. So in the first example here, it says potassium combines with oxygen to form potassium oxide and wants us to write an equation for the reaction. Now, one thing I'll say is for the rest of Chapter 8, it would be a really great idea if you had your notes from Chapter 6 on chemical nomenclature in front of you, or your tables on ions. We're going to be using that quite a lot as we go through the rest of this chapter, I should say. So have that in front of you. If you had any trouble with those chapters and writing formulas and compounds, go back and rewatch those videos. But I'm assuming that you have that in front of you, or you're at least comfortable doing those types of problems. So I'll be going a little faster on that side of things. So anyway, let's get back to this problem here. So potassium combines with oxygen to form potassium oxide. Write an equation for this reaction. Okay, so the first thing we need to notice is that obviously this is a combination reaction. Maybe in a quiz or a test it won't be so obvious, but here's a combination reaction. We have potassium combining with oxygen to form potassium oxide. Two distinct things coming together to form one new thing. Okay, and we're going to write that down with that knowledge. So we have potassium plus oxygen. And now oxygen, remember, is one of those diatomic elements. So it's going to be O2. So again, have those charts in front of you. If you do, it's going to be very helpful. Gives me, okay, potassium oxide. Now, how did I come to that? I'm just going to briefly say why it's the subscript 2 is there. Well, if you remember, potassium of the periodic table has a 1+ charge and oxygen has a 2- charge. So the whole formula unit needs to be neutral. So that means if you do the crisscrossing trick, I need 2 potassiums with a 1+ charge and 1 oxygen with a 2- charge. So that makes it neutral, the molecule. Okay, so we've written this out, but we're not done yet. We need to balance the equation, okay, using those skills that we learned before. So what are we going to do? Well, let me just balance oxygen here first. It's a little bit different maybe from some of our rules because we have a lot of elements over on the reactant side of the reaction, on the left side of the reaction arrow. So if I want to balance oxygen, I have 2 over here, I have 1 over here, so I could put a 2 there. Okay, so now oxygen is balanced and potassium is not balanced, so I need to put a 4 in front of the potassium. So I have 4 potassium on either side. And this now is my equation, okay, for the reaction, and it's balanced. So always make sure you balance the equations. Okay, let's do another example here. It says carbon dioxide gas is formed when charcoal, which is just carbon, burns with oxygen in the air. Write an equation for this reaction. Okay, so again, our product is carbon dioxide, okay, CO2. And this results from carbon okay, plus oxygen, which is O2 again. And this reaction is actually already balanced, so it's an easy one for us, remembering, again, that oxygen is a diatomic element, okay? So if we had a summary then of combination reactions, they're pretty easy, right? It can be any combination of elements and compounds that form one product. Again, two distinct things coming together to form one new thing. That's the combination reaction. Here's what the equation type will look like. And again, the products are one compound. Okay, so now what if we went the other way? All right, so this is the next section, which is a decomposition reaction. And as the name suggests now, we're decomposing something. So this is just the opposite. If you flip that other equation around, a decomposition reaction is when you have one compound breaking down into simpler substances. Okay, so it's just the complete opposite. You have one thing breaking down into multiple distinct things. So let's do some examples here. Okay, so the first example, it says molten sodium iodide is decomposed into its elements. Write an equation for this reaction. Okay, so first off, we're starting with molten sodium iodide is decomposed. So we're starting with sodium iodide. Okay, and when it mentions molten or solid, things like that, those are concepts we're going to be talking about, I believe, in the next chapter. So just keep them in the back of your mind, and I might write the states of matter as we go on, but that's something we're going to talk about more later. Right now, I just want you to get the concept of the types of equations that are going on here and how they look. So sodium iodide, okay, is decomposing into its elements. So that's going to be sodium, right, plus iodine. And remember, that's another one of the diatomic elements. Okay, so now if we write or balance this equation, I should say, let's see, I have one iodine, iodine, I should say, on the left side of the equation, 2 iodine on the right side of the equation. So if I put a 2 there, that balances that. Now I have 2 sodiums on this side of the equation. So put a 2 there. Now the sodiums are balanced. Okay. So this is the balanced chemical equation for the decomposition of sodium iodide into sodium and iodine. Okay. So let's go on a little bit. This one's a little trickier. So it says lime, okay, calcium oxide, and carbon dioxide gas are the product of a thermal decomposition of limestone, which is solid calcium carbonate. Write the equation. So don't get tripped up when it says things like thermal decomposition, high temperature, right? Those are, yes, important for the reaction, but you really want to hone in on the key words there, okay? The decomposition. Okay, so, we should know decomposition reaction, and that's one thing breaking down into multiple things, okay? So it's a decomposition reaction of sodium carbonate, or calcium carbonate, excuse me. So let's write that down. So calcium carbonate, so we have a calcium ion, which is a plus or 2+ charge, and a carbonate anion, which if you looked in your chart that I said to grab out from our anions, this is a 2- charge, okay? So the charges cancel out, okay? I need 1 2+ calcium and 1 2- carbonate to make the formula unit net neutral, okay? So this is what I get. Calcium carbonate is decomposing into calcium oxide plus carbon dioxide, okay? So this is my reaction, and actually I believe if we look at it, it's already balanced. So let me just double check. We have 1 calcium over here, 1 over here. We have 1 carbon over here, 1 carbon over here, 3 oxygens there, 1, 2, 3 oxygens. So we're balanced. So this is the decomposition of calcium carbonate to calcium oxide and carbon dioxide, okay? So A summary then on decomposition reactions is you start with one compound now, okay? And it's decomposing into any combination of elements and compounds, okay? Like we saw in the last two examples. So it's just the opposite of a combination reaction. So that's it for combination and decomposition reactions. In the next video, we're going to talk about single replacement reactions and double replacement reactions. So I'll see you there.